it's our great pleasure to welcome Rick and Bob and their messages from the team at NASA.
Wonderful. Delighted to have you, Rick and Bob. As always, you inspire us so much. Just a quick note for everyone, we have a small delay of 25 minutes, which is fine. NASA is more accurate than we are.
We get late too.
Yeah. So no, the thing with NASA and their presentation and Rick and Bob is that they really love to have interaction. And so we invited 3 schools from Moldova, South Africa, and Portugal. And they will pop on and pop up and pop in at all times to ask questions. And we are really excited about this. Thank you so much, Rick and Bob. And the floor is all yours.
Okay, great. Well, thank you all so much. And the whole Climate Action Project is totally exciting to us. And we really are impressed with everything you all are doing. As Cohen said, Bob Cullum and I work together, and we'll both be at. Bob, you want to say hi real fast?
Hi, everyone. Great to be here. Thanks, Rick.
So today, Bob's going to be running the slides here, but we do really, something is challenging is sending humans to Mars or solving the climate challenges that we face in our country really requires a lot of new thinking and a lot of new ideas. And there is a really, we believe, a strong interdependency between them, and we'll try to talk through that as we get into this. But we really welcome your questions and your ideas. It's only by working across the planet that we can solve these really incredible and exciting challenges, and they are exciting. We can solve them, and we will, but we have to all work together. Bob, let's go ahead and show the slides, please, if we can. So. Okay, great. So we're going to be talking about our future on making it our future on Mars possible. But really what this is mostly about is maybe a different perspective. And let me just succinctly summarize it. If we just view ourselves as citizens of, say, in our case, the United States, or in the case of last speakers of South Africa or wherever on this amazing planet, we get one perspective, and really the whole intent here is to say, let's have a larger perspective. We're actually advocating for maybe even a larger perspective where we are citizens of a solar system, where we use the amazing opportunities that exist in the solar system to help us to understand how to better take care of this incredible life-giving planet that in the past we've taken for granted. And that's going to be a key theme as we go through these slides this morning. Okay, next slide. One of the key points that we would emphasize is be careful about paradigms. You know, I live in Washington, D.C., and we get used to a certain way of doing things, and we use paradigms or ways of shortcuts of ways to understand things. And so a lot of times when someone sees on the right-hand side here the picture of this desert in Jordan, and then on the left-hand side we see this desert on Mars called Gale Crater, we just automatically assume they're the same, that, you know, they're going to be hot, they're going to be dry and arid. And in fact, that's a dangerous thing when you're talking about something totally new. You have to really question everything that is that you're assuming here, because in fact, on Mars, that the temperature drops. The air is, let me back it up. The atmosphere is very, very thin. It's like being at 150,000 feet in our atmosphere. Airplanes only go up to 35, 40,000 feet, and it's extremely thin. The temperatures drop 120 degrees at night. There are just some really major differences here that really make having human beings living and operating on the second planet and researching how that planet evolved challenging, but we are up to it. But you have to understand what you're dealing with. And then let's go to the next slide, and then there's a question we'll come back to it in a moment. Mars is not like that desert. It's more like extreme Earth, and this is a wonderful picture of going up K2. And Mars is like this times 1,000 if you really want to be blunt about it. And learning how to live there, land there, launch off that planet is really hard stuff. But we will solve it, just like we have learned to go up these kinds of mountains to the point where they're now almost routine. Here's a picture from Mount Everest. I believe it was last summer. Where in fact we have another problem. We've gotten so good at it that we actually have too many people going up it right now, and it introduces dangers that way. But that's not a different kind of problem. What we have learned to operate in that kind of environment, and we will learn to operate on Mars as well. And then we have a question from somebody. Can we try to answer that? And please introduce yourself if you can.
Hello, my name is
Hi.
Sandro. I'm
Hey,
a
how are you?
student from Portugal. I'm fine. I have a question. So NASA is identifying potential human landing sites on Mars.
Yeah.
So what are the needed conditions for an area on Mars to be used as a landing site? What are the conditions that you need?
So that's a great question. There are a number of things that we look for. First and foremost, we were trying to pick sites that are totally amazing for science in terms of teaching us how the planet works, how how it evolved, particularly in a number of areas, geologically and environmentally. We'll show you a slide here in a moment where Mars actually looked like Earth at one point, and then it went down a radically different path. And then one of the coolest questions is there life on Mars? And so being there, and then so that's like a big piece. But then the second piece is making sure humans, when they're operating there, such as yourself, maybe, where they have the resources they need. And one of the big resources we now know is Mars had oceans and had rivers and all that kind of stuff. And a lot of that water is still there. It's just frozen because the planet's there. So one of the things we fully expect is to go to places where there's lots of water ice there that we can use for all the things human beings use water for. Okay, and then we got another question. Yeah, go ahead.
When would be the quickest time, the earliest time when we could go to Mars? Like I could go to Mars.
I love that question. So we think that humans can probably start heading out there in the mid 2030s. So how old are you right now?
I'm 11.
Up, so you'd be like 25, and that's like a perfect age for an astronaut. And so we think that that's probably the time frame. Could be a little later, could be around that time frame, but that's the time it's going to take. And you'll see some of the challenges that we have to put and solve to go do this, but you'll see that here in a moment. Okay. Thanks for the great question too. Okay, Bob, let's go to the next slide. Okay, so when you have these dangerous situations, the thing that we have learned with Mars is you do it step by step and you earn your way. And that is exactly how mountaineers did it, going up the things. It's exactly how humans did it going to the South Pole in Antarctica. They just worked their way up to it. And here is an example of these rovers that we have sent to Mars. So you have the Sojourner rover, which went in 97. College and university student groups build rovers this size now, and they can't operate on Mars usually, but this technology has really become available. But the first ones that went, that was not the case. Then you have Spirit and Opportunity. They went in 2004, and you can see they're bigger. And in fact, they were designed to last for 3 months. Opportunity just died last year. And so it lasted for literally almost 15 years longer than we expected. And the only reason we lost it was because we had a global dust storm, which happens on Mars. We don't have those on Earth, but we want to understand why they occur on Mars. So that, and then you see on the top of that, below that white thing sticking up, that's a camera, or the solar rays. And with the sun all blocked out because of the dust storm, it actually died. The batteries discharged to the point where we lost it. And then we sent Curiosity, which is a whole nother class, which is essentially a metric ton, but that's the size of an SUV, a large car. And we had to go through all kinds of efforts to land something that big because the Martian atmosphere is so thin that it doesn't really slow you up like it does on Earth. but it's enough that you have to ignore it because you can burn up if you're not careful. And so we normally show a video of that, and we're delighted to provide it. But that is really hard. The human landers that maybe some of you will be on will be 20 times that at least. And that means it's 20 SUVs or large cars stapled together, and you have to land that thing. And that is a whole different set of problems that we will have to solve. But the point is, we didn't start with that Curiosity rover. We started with that small Sojourner, and we worked our way up. We learned how to master the challenges, and then we've been successful. The United States is the only country to date that's successfully landed something on Mars. We are proud of that, but we want to be out of that business. We want to have as many international partners as possible landing things at Mars, because then the entire species will learn so much more about our second planet. And that is very exciting. And we work very closely with many international countries to make that happen. And we have another question that we can try to answer. And Bob, you can go ahead and advance to the next slide. Okay, yes, please go ahead and ask your question.
Yeah.
Oh, I'm in the show.
What's your name?
How much pollution goes into the atmosphere when a shuttle blasts off?
Oh, I don't know that exact question, but it's a great question. And it depends on what you're using. So for example, when the space shuttle launched, it had these rockets on the side, and that's kind of some nasty stuff that gets there. We are moving more and more towards using oxygen and hydrogen for launching things off the Earth. Oxygen and hydrogen are great because when they combine those two atoms, it actually just makes water, just pure water. And so that's increasingly and you get a better performance out of it. It's just hard to manage the hydrogen. So, so the good news is we're moving towards rocket technologies that are actually pretty eco-friendly, in my opinion. Okay. Okay, next. Okay, so on this slide, let's talk this, then we'll take a few more questions. So I want to introduce you to the major parts of a Mars mission, because we're going to focus on a few of them, but you have that launch vehicles. You got to have a lot of mass up there to keep human beings alive on the second planet. And these, it's not just, this is an example of the Space Launch System that NASA's building, but there's a lot of companies and a lot of countries all across this planet that can launch amazing things into space. But you really need bigger rockets to push all the things that we need for Mars mission, and they're in development. Then you have to land at Earth, and that's what that near-Earth crew vehicle is. And when you land, there is literally flames coming around the vehicle because it's so hot entering the thick Earth atmosphere. And then we're going to focus a little bit on this Mars transfer vehicle because we call this the mothership. This is actually what's going to keep you alive. And I'd like to ask the classes that are online, does anyone here, I want you to please guess how long a human mission to Mars will take, if you would please, for me. Just give me in the chat log, maybe show me. Okay, Ernest says 6 months. Any other guesses? Okay, so 6 months is it takes 6 to 9 months to get out to Mars. Then you have to stick around Mars for about 500 days, and then it's going to take 6 to 9 months to come back. So altogether, when you head out to Mars, you're going to be gone for 3 years. And that's a tremendous time. So this Mars transfer vehicle is really your home. Yeah, go ahead. Did you all have a question?
Good afternoon. Yes, I have a question.
Absolutely.
Carbon. Oh, sorry. Because of the carbon footprint of launching these missions, is NASA planning on funding mitigation for climate change?
I couldn't hear your last part. Is NASA planning on
funding mitigation for climate change?
Well, we don't launch that often, so that's one thing that helps. And I would need to see what else, I don't know what other thoughts are there. And the good news is that if if you're using oxygen and hydrogen, you're actually just generating water, which a lot of these rockets are moving to. It's a good question. You know, I would be more worried about airline companies, you know, and the growing volume of traffic that's there, because they're using just regular petrochemical, aviation products, and that's a much bigger problem in general.
Thank you.
Okay, and another question.
Hello,
And yeah, what's your name?
I'm Ruben.
Hey, nice
And
to meet you.
nice to meet you too. Um, I was wondering if there is space waste from the missions, and if so, what is being done about it?
Oh, save that question. We're going to come to that. That's a great question. Thank you. All these questions are great. So thank you. Just give us a sec. We'll get to that. Okay.
Yes.
Okay, great. So let's keep talking through these. And then we have to have tugs for pushing cargo out to the second planet. You have to have comm. When you get down on the surface, you have to have a Mars surface suit. That's not a space suit because you're on Mars. And that's a different beast because there's dust. You have to worry about if there's life on Mars, whether or not it can get inside the suit, which might be dangerous for humans. You have to have a habitat in laboratories because if we're going to the second planet, we're going there to study how it works. And that is really relevant, we believe, to the things you all are talking about in trying to envision today. You have to be able to get around, so there's a rover, and eventually when you come home, you need to be able to launch off the planet, and that's this Mars Ascent Vehicle that you see in the center. So those are like all the big parts you have to have, and we're going to focus a little bit on this Mars Transfer Vehicle right here. Let's go ahead, Bob, to the next slide. So the Mars Transfer Vehicle, aka the mothership, this is what people are living in most of the time. And if the landers are broken, you're going to be in there for that full 1,100 days. And so we really need to think about what human beings need in that thing. And there's a lot of ideas out there, but the students today can make a lot of contributions to this idea space. And it's really a very exciting area there. One of the things is that we human beings, what's interesting is that if I worked in a flight control room in Houston for NASA for many years, and if we had a rule, it's in space is dangerous, on the surface is safe. This is one of those paradigms or rules of thumb that, being in space is dangerous. And I'm actually kind of surprised that when people in those flight control rooms think about going to Mars, they think about being on the surface is safe and in space is dangerous. Well, in point of fact, I would like for y'all to, Bob, go ahead and show the next part of this. Human beings actually across all the missions, and this is human beings from all over this planet, have had 60,000 human days in zero gravity. And that number is actually bigger than that now. And that means that if 2 people or 3 people spend a day in space, that's 3 human days. But that is a lot of time in space. And we've had this much time on our second planet, which is 0 days, because human beings haven't figured out how to land there yet or get there and land, but we will. And so my only point is that if you recall those rovers, you have to kind of step your way up into a solution and learn how to do this properly. The good news for Mars, sending people to Mars, is that we have an amazing International Space Station that has taught us about a lot of these things. One thing I would point out on this slide is how little time, though, one human being has spent in space. And so the longest time any human being has spent, it was a Russian, was 438 days. And remember, I told you those Mars missions are 1,100 days. So we really need to understand how different types of people, like men, women, different culture, racial compositions and all that, because their bodies all work a little differently. And we need to make sure that we have a statistically sound set of data to understand how the human being will operate in these long periods in weightlessness. But we'll get there and we'll learn how to do that. Bob, let's go to the next slide. And there's a question from the mission. Are you aiming to gather resources to bring back to yes. So we are aiming to use resources at Mars. I love that question. But it's not for the reason you think. We're actually, for that Mars Ascent Vehicle, we want to use water at Mars as a propellant. We can break it down into oxygen. And instead of oxygen and hydrogen, we actually would use oxygen and methane. But the methane we can make with the water at Mars. That gives you a hydrogen atom, and then you can mix it with the carbon in the atmosphere to make methane. And that really makes these much more inexpensive missions, and it's still very clean. And that's really the big one. We also use it for drinking water and for other purposes, but the big one is to actually make propellant. And there's another question.
Yes, my name is Bogdana.
Hi, nice to
and I
meet
wanted to ask, nice to meet you too. When is NASA planning on sending the next team to Mars?
So we have, right now, we have people in space, in the space station every day of the year, along with a lot of other, with Russia and the Europeans and the Japanese. We probably will not be ready to send humans to Mars until the 2035, 2037 timeframe, but we're working extremely hard to make that happen, which means that for students in school today, like you guys, some of you all are could very well be on those first crews heading all the way out to Mars. Which is totally cool. Okay, one more question, then we'll keep pressing. Is there another question?
Oh yes, sorry.
Okay,
It's
that's no
me
problem.
again.
Yeah, hey.
So I have another question. So when is it expected that if you already have the technology, when is it possible that when the astronaut arrives on Mars, he can, for example, enter an infrastructure? I don't know what kind of technology you will have, but an infrastructure where he can take off his gear and there will be already oxygen waiting for him in.
Yes, so that's like trying to make the atmosphere more Earth-like.
Yes.
That's not going to happen anytime soon. That is really radical technology. But we will have habitats, and we'll have, and we may even have domed sort of small cities that are completely self-sustaining. And that's, so that's where the step I think it'll happen first. And then eventually we may learn enough about taking care of planets that we can do those kinds of things without damaging the actual ecology dramatically there. And so those are things we have to think about. Let's go ahead and go through a few more of these slides, and we'll come back and questions. So please keep your questions. So the big thing in a mothership or Mars transfer vehicle, really the space station teaches us these things. So one of the number ones is we would keep these crews super, super busy doing research. And on the way out to Mars, they'll be doing the same thing. They'll be learning how materials work. They'll be studying the solar system, other star fields. They'll be looking at Earth from long distances. They will be growing plants and see how they grow in zero gravity. And on the way back, we'll probably be analyzing samples from Mars. And we really keep these people super, super busy. They also have to exercise, and this is really important because when they're in zero gravity, their bones are shrinking because there's no work on the bones, and then their muscles do the same thing. So what we do is we make them exercise, and if someone in the chat log can guess how many hours we make them exercise each day, I would love to see that. Some guesses. Okay. So, thanks. It's not 7. Okay, and that's but it's cool that you're guessing that. Thank you. We actually make them exercise about 2.5 hours, so it's about an hour and a quarter on cardio type exercises. So here you're seeing a guy where you can see the blue things going around his shoulder. Those are bungee cords. There's no gravity, so you can't just run on a treadmill because you just float right off of it. So the bungee cords pull you down onto the treadmill so that you can actually exercise. And then we have the equivalent of bicycles, we have the equivalent of rowing machines, and those are the things we do to make sure they stay in shape from a cardiovascular standpoint. And then on the space station, we actually, because they're up there for 6 months at a time, we've actually had to learn to use weight machines. You can't use weight machines because they're weightless in zero gravity. So we have the equivalent of like Soloflex machines, where you have basically big rubber bands, you can think of it that way, for exercising muscles, and they work incredibly well. They're big, and we have to get them smaller to make sure that we can send them all the way to Mars. And then the other piece here is we have we also have to take care of the crews. They're in a very stressful environment. A piece of space junk can hit their modules, and if it does, they're going to have to be out of those modules so fast it's not even funny. and there could be fires, there could be all kinds of problems. And so when they have their off time, we have to protect them and make sure they can enjoy the time. And here, I love this picture because it's someone having coffee, like many of us would, and enjoying the amazing view over the Earth. But this is a view we take for granted, and it's an important view because when you look at this view, what you realize is that when you're looking out that window, you know that you can, if something goes wrong, you can get into your capsule and within less than a half an hour, and you can probably be landing on Earth in 2 hours if you need to be. Maybe not exactly where you would normally want to be, but you can be back on the safety of this amazing planet. When you go to Mars and you light those engines to head out on that 3-year mission, you are gone for 3 years. And what that does to the way the human being views things is really critical, and I think sheds light on a lot of the things that we maybe take for granted on this planet. And that is a perspective that we'll explore here in just a second. Bob, let's go to the next page. And so that actually brings to this point that eventually on a Mars mission, we are going to have, you're going to have to know where to look in the window to see a little tiny blue dot and its white moon off into the distance. And then you're going to have to know where you're in the window, where to look to find the tiny little red dot of our second planet. So, what the human being experiences there in that vast emptiness of space, we cannot even imagine because human beings have never been there. Okay, let's go to the next slide, please. Okay, so here's a quick summary of the things we think we learned from exploring our second planet for our first. And let's go to that next one. Number one, Mars, as I said, actually was like Earth. It actually looked like Earth at one point. And so it is an amazing thing that we can go there and actually put scientists, and maybe some of you all will be the scientists that go to dig into the dirt, to understand the geology of what happened, to understand what happened to the environment, because it ended up being a very frozen planet, which is a potentially a fate that was a fate that has happened to this planet where we went into ice ages. And so being able to get scientists on the second planet and really understand how they work is key for being able to understand how they think. As an engineer and scientist, we are taught that you never make decisions based off one data point. And unfortunately, we're trying to manage this planet based off the one data planet being on this one. And by getting out into our real home, which is the larger solar system, we can actually understand how other planets work and evolve so that we can bring that knowledge back to Earth. Next slide, please. And then there is a ton of things that we can do. I'm not going to go into all of these things, but Mars has glaciers on it. It has dust storms like this planet does. It is an incredible analog for this planet. And by being able to compare the two planets, we are able to really understand better how this planet works. And we're going to need a lot of creative ideas on how to do this. Next slide. Sorry to be running that. And then the second thing Mars does is when you go, it shatters complacency on Earth. Because of the cost of going to Mars, everything has to be recycled. And you have to think about all that. Could you do that without going to Mars? Yes. But the fact of the matter is that by going to the second planet, we don't have the choice. It is so hard to do it. You have to recycle everything from urine to water. You have to make sure the air is clean. You have to be able to grow food. And you have to do that all in very closed ecosystems. And that design challenge really forces us to think differently. And that will have significant ramifications for how we are able to come up with technologies that take care of this planet. Next slide, please. And even trash is a resource. So it was a great question about that. But you don't throw things away. Plastic becomes a feedstock for 3D printing. Poop and pee becomes a fertilizer for gardens that are here. And everything is a resource. So we have to really change the way we perceive of this. And really, Mars just forces us to do it. Next slide. And then that change perspective is really the key thing. And I would just point out one thing. When humans went to the moon, They came around, and this is a picture from Apollo 8 down here in the lower right-hand corner. And that view of the Earth and the Black Sea of space was transformative for many, and many attribute that the environmental movement actually started there, where you see the fragility of this incredible planet. When we have this larger perspective that the Earth is even tinier, it is going to radically transform our understanding of what's possible, and what we need to do to take care of this just exceptional planet that we often take for granted. And lastly, Mars is an international effort, just like you guys are doing this internationally. And when you learn to work together, you are able to come up with things that no one ever thought of, because you bring all those different perspectives together. And that is powerful and completely enabling, not just for Mars, but for managing the problems of climate change. Next slide, please.
I'm sorry
And
to interrupt.
yeah, this is it. This is it. We're done.
Okay,
And
so
so
sorry.
Mars is a human effort, and we need ideas just like we need it for climate change. And you students are amazing, and you will be able to make incredible contributions. And we really, for NASA, we need those ideas, but the climate change effort also does. This is our Twitter and also our X thing if you want more information. Sorry, Kuhn, we went over, but the questions were great. We really appreciate them.
I'm so sorry. I really hate doing this. Because
That's okay. No, we know you had
so
to.
interesting. Yeah.
Yeah. Well, we
No,
thank
but-
everybody for their great questions.
Yeah, I love the synergy with the students. So thank you so much for asking those questions. The thing is that our next guest, we urgently need to bring him on the show.
Yeah. No, thanks.
But thank you so much, and we really, really love working with you, and we are so much looking forward to continue doing this. Thank you
Yeah,
so
we
much.
feel the
Rick and
same.
Bob.
Yeah,
Thank
you
you so
guys are
much.
rocking. So thank you. Take care.